All right, so in this next chapter, chapter 5, we're talking about linear functions. Now, a linear function is just a line. That's all it is. It's just a line. These lines have different slopes, but nevertheless, they are still just lines. So, what we're going to be talking about here is identifying a linear function. Like, just by looking at an equation, can I tell that it's linear? And then secondly, graphing linear functions as well. How do we do that? Again, it's just graphing a line, but we have to make sure that we get the points accurate. So in this first example, we have a situation, a race car can travel up to 210 miles per hour. If the car could travel continuously at that speed, then y equals 210x gives the number of miles the car would travel in x hours. So essentially, you can see on the graph that if the car were to travel at 210 miles per hour, then after 1 hour, the car would have gone 210 miles. After 2 hours, it would have gone a total of 420 miles. And that's because it's just another 210 miles further. At 3 hours, it would have gone 630 miles, 4 hours, 840, 5 hours, 1,050 miles. Now, how can we tell that this is a linear function, right? Well, by the graph, we can tell that it's linear because of it being a straight line. But from the table, it's a little more obvious. From the table, so let's put the points down from that graph into this table. So we have the points 1, 210, 2, 420, 3, 6, 30, 4, 8, 40, and 5, 10, 50. Now, looking at this table, we can really see the change in x and the change in y. We can really see that this is linear because a linear function will have a constant change. Being a line, it means it's going to change the same amount every time. So if you look at the x values, right, notice that the change is plus 1, right? From each x value to the next, right, it's increasing by 1, plus 1 every time. And when you look at the y values, it's increasing by a constant amount as well. It's always increasing by 210, plus 210, plus 210, right, plus 210, right? So the x is a constant change, right? It's going up by 1. And the y is also a constant change. The fact that it's going up by 210. Constant means, consistent means the same. So it's always going up by the exact same amount. 1 for the x's, 210 for the y's. So part B and part C here that we're going to answer have already been done, right? Use a table, check x has a constant change. And we can tell that it does have a constant change. Its constant change is 1, right? And then part C says check the y's have a constant change. When we look back at that, we can see that it already does. We've already done that, right? It does. Its constant change is 210. Now, using the answers from before, what change in x corresponds to a change in y? So as x increases by 1, as x increases by 1, y increases by 210. It's always changing by those exact same amounts every time. The constant changes every time. So all linear functions do this. All linear functions have a constant change in x and corresponding to a constant change in y. So will a nonlinear function have a constant change in x that corresponds to a constant change in y? The answer is no in this case. Only linear functions have a constant change in x that corresponds to a constant change in y. Nonlinear functions will not have those constant amounts. So nonlinear won't have constant change in both x and y. So to demonstrate that, sort of illustrate what's going on, here is a nonlinear function, y equals x squared. This is a nonlinear function, and the table is shown to us as well. So if you look at this table of y equals x squared, you'll notice the x values are constant, right? The x values are increasing by 1 every time, which is nice. You know, that's something we would see in a linear function. However, look at the y's. The y's are not a constant change. The y's, it changes at +3, then it's +5, then it's +7, then it's +9, right? All these values are different numbers. There might be a pattern, sure, but they are still different numbers. They are not constant, right? They're always changing. So because of this, because they're always changing, that means it's not linear, right? A linear function has a constant change in x and a constant change in y. This does not do that. All right, we are going to skip page 201 because it's about a proof and we don't really want to deal with that. Not really something to spend our time on. Okay, but now let's look at these problems. These problems are going to do mainly what we're here to do today, which is identify if it's linear, yes or no, it's linear or it's not. And then if it is linear, let's graph it. So how can we tell if it's linear or not? Well, you'll notice an equation in standard form if it's linear. There's also another form, which is slope-intercept form, which is y equals mx plus b. Both of these forms are forms where you can tell that it's linear. Okay. Hold on, the thing's a little laggy right now again, but it'll get over it. All right. So I'll deal with it. It's fine. So in example A, you know, it's asking, hey, is this equation linear? This 5x plus y. The answer is yeah, that is linear because it's in standard form. Standard form, as we saw earlier, standard form is ax plus by equals c. And this isn't standard form because you can see that the 5 represents the ax part, the plus by, I'm sorry for the handwriting. I'm putting my pen down and it doesn't write until like after a second, so it's a little laggy. And then the 10 is equal to the c part. So you have 5 being the ax part, you have the 1 part being the 1y being the by, and then the 10 being the c. So a is like the 5, b is the 1, and c is the 10. Now, we can tell that it's linear just by looking at it and seeing that it's in standard form. So yeah, we see, hey, that's standard form, so it must be linear. But how do I graph it? Well, I'll tell you for one thing, we cannot graph it while it stays in standard form. That's what they're doing here. They're rearranging it so it's no longer in standard form. But how do they do that? This is the part of the math that's probably the most challenging for us, okay? So it's something that we need to get, a lot of practice on, right? My pen's working just fine now. So here is the original equation, right? It's standard form. But what we need to do before we graph this line is we need to rearrange it into what I've mentioned earlier was slope-intercept form, y equals mx plus b. We really want it in this form for us to graph, not in the current form, which is ax plus by equals c. We don't want that standard form. So how do I do that? Well, how I write it in this form is my goal is to just isolate this y. You'll notice that y is the only thing on the left side of this equal sign. Everything else is on the right side of the equal sign. So that's my goal. That's my intention. I'll be able to set it up in that format if I can get the y by itself. So here's this y that I need by itself. In order to do that, I need to get rid of the 5x here. And it's pretty simple. Because I'm adding the 5x, because it's a positive 5x, I'm just going to subtract 5x in order to cancel it out. But if I subtract it on the left, I have to subtract it on the right as well to keep the equation balanced. So what happens? On the left side, 5x minus 5x is 0, right? Essentially, canceling the 5x out so that the y is now the only thing that's there. And on the right-hand side, remember I have to subtract 5x over there as well because I need to keep, whatever I do to the left side, I have to do to the right side to keep things balanced. So keep in mind, you cannot combine these numbers, 10 minus 5x, because they are not like terms, right? If it was just 10 minus 5, then sure, you can combine them. But it's 10 minus 5x. There, you can't combine them. If it was 10x minus 5x, you could, because then they're like terms. But again, not just 10 minus 5x. 10 is just a regular number. 5x is an x term. So they're different. They do not go together, meaning you have to keep them separate. So you can write this as how they've written it, which is 10 minus 5x, just writing the two terms separately. Or I'm going to write it slightly differently. I'm going to write it as negative 5x plus 10. It's the exact same thing as 10 minus 5x. You'll notice the minus sign is still with the 5. And because 10 started off positive, it still has a plus sign there. So it's still equivalent, still good for us to use. So that's the part of the math that you guys are probably going to struggle with the most, is just rearranging it into this format. So now it's in the correct format. The y is by itself. Now this is easy to graph. So how we're going to graph it is we're going to pick values of x. You can see that they've picked negative 1, 0, 1, 2, and 3. They've picked those values of x to plug into this function and then get ordered pairs to graph. So they picked a negative 1, right? That you see on the table, they've picked an x value of negative 1. So what they did is they took this equation and they plugged negative 1 in for x. And when they did that, they got the result. They got negative 5 times negative 1, which is positive 5, plus 10, which makes an answer of 15. So they got the order pair negative 1, 15, right? You can see that over here. Negative 1, 15. So they graphed that point. You can see that point being graphed there. So then they decided, okay, let's take another number. Let's take 0, right? So plug in 0, negative 5 times 0 plus 10. Well, this results to be 0 plus 10, which means the number is 10. So they graph that point, 0, 10, from their table. 0, 10 is graphed here, right? And they did that for every single one of these. They did it for 1, they plugged 1 in. So they did y equals negative 5 times 1 plus 10. They also did y equals negative 5 times 2 plus 10. And they did y equals negative 5 times 3 plus 10, right? They plugged in 1 and they got 5. They plugged 2 and they got 0. They plugged 3 and they got negative 5. So let's see how they got those numbers. Negative 5 times 1 is negative 5. And negative 5 plus 10 is 5. So 1, 5 is a point for their graph. And you can see that that point is there. When they plugged 2 in, they got negative 10 plus 10. Negative 5 times 2 is negative 10. Negative 10 plus 10, which is 0. So they got the point to 0, right? That's this one. That's plotted right here. And then when they plugged 3 in, they got negative 5 times 3, which is negative 15 plus 10, which ends up being negative 5. So they got that point, 3 and negative 5. And they graphed that point there. So they graphed those points, and then they saw their line. Remember, your graph should be a straight line. A linear function is always going to be a straight line. So let's try to do this same exact thing for example B. Example B, this equation is linear, right? And we can tell it's linear because it is written in standard form. Remember, we talked about this. How do I tell what's written in standard form? Well, standard form, remember, is ax plus by equals c. And that's this format because we have negative 4x, so a is like the negative 4, plus 1y, so b is like 1, equal to a number, c, which is 11 in this case. So it is in standard form. So I can tell you that it's linear. But in order to graph it, I can't leave it in standard form. I have to rearrange it into what's known as slope-intercept form, right? Needed to be y equals mx plus b. I need it to look like that for me to graph it. So to graph the function, I first need to solve the equation for y, which just means get y by itself. So what I mean by that is let's take the equation we have, negative 4x plus y equal to 11. I need to just get the y by itself, right? Because I need the y equals mx plus b. So I need the y by itself on the left. So that means getting rid of negative 4x. Now, how do I get rid of negative 4x? Well, since it's a negative, right, I'll add it. Add negative 4x plus 4x becomes 0 and goes away. So let's simplify what happens here. Negative 4x plus 4x. So the left side, it cancels out. That's going to disappear. It's 0x, just leaving you with the regular y by itself. On the right-hand side, remember you're adding 4x over here because you have to keep the equation balanced. Remember that these two terms are not like terms. You cannot add them together, or at least you can't combine them together. So, you're not going to get 15 or 15x because you can't do 11 plus 4 here. They're not like terms, so you keep them separate. It's 11 plus 4x as the result, or, which is what they have over here, or you can reorder them to just say 4x plus 11. That works too. So that's the equation that we can use to graph. Y equals 4x plus 11. So what we're going to do is we're going to plug values in for x and get those, complete our table, and then graph those points. So the table's already halfway made for us. It wants us to use these numbers for x. So let's plug those in. We'll start with negative 4. So we'll plug negative 4 in for x. So this is y equals 4 times negative 4 plus 11. Now this comes out to be negative 16 plus 11, which equals negative 5. So we're going to put that in our table for negative 4. Now we're going to plug the negative 2 in. So when I plug negative 2 in, we'll have 4 times negative 2 plus 11. This makes negative 8 plus 11, which is a positive 3. So that 3 goes in for the negative 2. Now we'll plug 0 in. That was the next one. Y equals 4 times 0 plus 11. 4 times 0 is 0, and 0 plus 11 is 11. So we get 11 for that 0. Now we'll plug 2 in. So when I plug 2 in, we have y equals 4 times 2 plus 11. 4 times 2 is 8, and we have 8 plus 11, which is 19. And then we plug 4 in, the last one. Y equals 4 times 4 plus 11, which is 16 plus 11, which makes 27. So the last one there is 27. So now we're just graphing these points. So this graph's kind of tricky to use because it's scaled weird. So you'll notice that here we're going by 1. So this would be 1, 2, 3, 4, which means this must be negative 1, negative 2, negative 3, negative 4. So my first point is to graph negative 4, negative 5. So negative 4 is going to be here. And notice the y-axis. They're going up by 10. So that would be negative 10, negative 20, negative 30. So if I need to graph negative 4, negative 5, negative 5 is going to be halfway between here. So negative 4, negative 5 will be roughly there. Really tough to use that graph because it's scaled really, really funny. But there's where negative 4, negative 5 would be. Negative 2, negative 3. So negative 2 is going to be here, and negative 3 is going to be, or I'm sorry, positive 3, which would be slightly above it. So positive 3 would be about there. Remember, that's where 3 is because this would be 10. This line would be 10. Halfway between there would be 5. So 3's got to be just a little bit lower than that. Then I have 0, 11. So if this is 10, then 11 is going to be just above it. So right here. I have 2, 19. 19 is going to be right below 20. So 2, 19 would be right about there. And then 4, 27. 27, remember this is 30 here. So 27 would be just below that line, about there. So there's my line. And again, it should look roughly like a straight line. It's supposed to be a straight line. So our graph is not perfect, but it does resemble a straight line, which is good for us. That is our graph. All right. We're going to fast forward here to number 7 and end the video after number 7. All right, so number 7, again, determine whether this is linear. Well, looking at this equation, we can see that it's in standard form again, right? AX plus BY equals C. We can see that the A value here is 6 because we have the 6X. We have the B is equal to 1 because we have just 1Y. And then we can see that 12 is our C value. So it is in standard form. So recognizing that it's in standard form, it is linear. So we know that that's true. So now how do we graph it? So in order to graph this, right, what we need is we need to write it in a better form. We need to write it in y equals mx plus b form, right? Our goal before we graph it is to rearrange this equation. So remember, our goal is to get the y by itself. In this case, to do that, I need to move my 6x. Since it's a positive 6x, we'll move it by subtracting 6x. So remember, we're doing that on both sides of this equation. So on the left, 6x minus 6x is going to cancel. So the y is going to be by itself, which is, again, what I'm trying to do. And on the right-hand side, I just have 12 minus 6x. Remember, you cannot combine those terms because they're not like terms, so keep them separate. So you can write it as 12 minus 6x, or you can write it as negative 6x plus 12. Either way would work, okay? So that's going to be the equation that I use to graph. Negative 6x plus 12. Or again, you might have 12 minus 6x. Same thing. Now here's the thing, right? Is what values am I going to plug in for x? You know, I get to kind of choose my own. When you get to choose your own, I recommend that you always choose these numbers: -2, -1, 0, 1, and 2. I'm going to make a table over here to sort of organize my order pairs. So these are the numbers I recommend you choose. They usually work pretty well every time. So if you don't know which numbers to plug in, just plug in those numbers, okay? So let's start by plugging in -2. When I do that, I'll have -6 times -2 plus 12. So I plug in -2. Now what I get out of this is -6 times -2 becomes a positive 12, and then plus 12, right? That's positive 12. 12 plus 12 is going to be 24. So we'll have that point, -2 and 24. Now let's plug in -1. -6 times -1 plus 12. That's going to be -6 times -1 is going to be positive 6 plus 12, which is going to make 18. Now let's plug 0 in. Y equals -6 times 0 plus 12. -6 times 0 is 0, so that's just going to be 0 plus 12, which of course is 12. If I plug 1 in, -6 times 1 plus 12. -6 times 1 is -6, and -6 plus 12, that's going to make a positive 6 as an answer. So there's the next point. And then I have -6 times 2, plug in 2. So -6 times 2 is -12 plus 12, which makes 0. -12 plus 12 is just 0. So there are my order points to graph. So when I graph it, so -2, 24, so that's going to be roughly right about there. -1, 18, so -1 is there. 18 would be just below 20, so about there. 0, 12, 0, 12 is going to be just above the 10. 1, 6, so here's 1. 6 will be right above the 5, which is right about there. And then 2, 0 would be here. So again, you can kind of see that there's your straight line. Now, how do I know if this is right? Also, how can I avoid having to do all of this math here? Well, it's simple. Remember, we talked about at the very beginning is that linear functions have a constant change in x and a constant change in y. So you notice all these x's that I chose have a constant change, right? They're all increasing by 1, right? Plus 1, plus 1, plus 1, plus 1, right? Constant change in x, which means my y value should have a constant change as well. You'll notice that I'm subtracting 6 from 24 to 18. I'm subtracting 6 from 18 to 12, subtracting 6 again, subtracting 6 again, right? I have a constant change. So without having to do any math, I would know that if I want to plug another number in like 3, right? If I increase by 1 again, that my y value will just decrease by 6 again, which means that this would be -6. If I wanted to find 4, I could just increase by 1 means I'll be decreasing by 6 again. So I subtract 6 one more time, and that'd be negative 12. Right? I can get these numbers without actually having to plug them in to the equation and solve them. So if you remember that, then you would know that you can just find these numbers by continuously subtracting 6 every time, because you'll see that that's the constant change amount. That's the amount that y is decreasing by or changing by every time. So there are little things like that that you can look out for. So just be mindful of that when you're doing some of these problems, okay? All right, we're going to end this video on that note. So your homework problems are going to be from this section here. It's either, I think it's 1 through 6, if I remember correctly. So no, the first 6 problems. Remember, it says, if it's linear, graph it. So if it's not linear, then you don't have to graph it. So you're only going to graph the ones that are linear. Just keep that in mind. All right, that's going to do it. I'll see you guys in the next one.